children, today we are going to start with a new topic of class 11th unit and dimensions, and the name of the topic is principle of homogeneity. The objectives related with the topic are: state the principle of homogeneity. What is the use of the principle of homogeneity? We shall also discuss some numericals based on this principle. Now let's start with the explanation. Children, do you know what is principle of homogeneity? The principle of homogeneity states that dimensions of each of the terms of a dimensional equation on both sides are same. The principle of homogeneity helps us to convert the units from one form to another. For better understanding of this topic, we shall discuss some numericals. Students, we have to check the correctness of the equations of motion using the principle of homogeneity. Students, do you know there are three equations of motion? V equal to u plus at, v square minus u square equal to 2as, and s equal to ut plus half at square. These are the equations of motion when the body is moving in a linear path. Let's start with our solution. Children, as we know, v equal to u plus at. V is velocity of light and has dimension of lt minus 1. Students, I hope you have learnt all the values of these quantities. Now right hand side is u plus at. U is again velocity, so its dimensional formula is lt minus 1, plus a is acceleration, its dimensional formula is lt minus 2, and t has dimensions m0, l0, t1. On combining all of these, we get m0, l1, t minus 1. If we compare it with the first equation, we will get the same answer. Hence, we have proved that the equation v equal to u plus at is dimensionally correct. Second equation is s equal to ut plus half at square. S is distance, so it's having dimension of L, that is m0, l1, t0. Right hand side we have ut plus half at square. U is again velocity, so its dimension is lt minus 1. T has dimension capital T. Half is a constant quantity and hence it has no dimension. A has dimensions lt minus 2 and t square has dimension m0, l0, t2. On solving, we shall get the answer m0, l1, t0. Hence, students, we can conclude from here that LHS is equal to RHS and the equation S equal to UT plus half AT square is dimensionally correct. Now let's start with the third equation. V square minus U square equal to 2AS. Left hand side. V square has dimensional unit LT minus 1, and because of the square, it is LT minus 1 whole square. Similarly, U square is also velocity, that is, its unit is LT minus 1 and again square. So, we need not to subtract here. As we know, we can subtract only those quantities which have same unit. That is why the unit will become LT minus 1 whole square. That is m0, l2, t minus 2. Considering right hand side 2as. 2 is a constant, so it does not have any dimension. A is acceleration. It has dimensions lt minus 2. S again is distance, so it will have the dimension L. So ultimately your answer will become m0, l2, t minus 2. On comparing with the left hand side, we will get same value as that of the right hand side. Hence, we can say this formula is dimensionally correct. The second application of principle of homogeneity is we can derive a correct relationship between two different quantities. Now let's find the dimensional formula for pressure. Students, pressure is equal to force over area. That is, pressure consists of two different quantities, force and area. So, force has the SI unit M1 L1 T minus 2. I hope you have all learnt these dimensional values. A has the dimensional formula M0 L2 T0. So, on recombining them, we will get the answer M1 L minus 1 T minus 2. This is the dimensional formula for pressure. Hence, using the principle of homogeneity, we can derive the dimensional formula for various different quantities. Here, force equal to mass into acceleration, that is, F equal to m into acceleration can be written as length over time square. So, the relation becomes m into L over t square, that is m1 L1 t minus 2. Hence, we can find the relation using dimensional analysis. Let's study another application of principle of homogeneity. Let's convert one system of unit to another. Let's take an example. Convert 1 joule into erg using dimensional analysis. Students, as we know, work done is equal to force into distance. According to the formula, 1 joule becomes equal to 1 Newton into 1 meter. As force equal to mass into acceleration, therefore 1 Newton becomes equal to 1 kg into 1 meter per second square. In 1 kg, there are 10 to the power 3 grams, and in 1 meter per second square, there are 10 to the power 2 centimeter per second square. Hence, on putting these values, we will get 1 joule equal to 10 power 5 into 10 power 2, which is equal to 10 power 7 erg. In this way, we have converted 1 joule into erg. Children, I hope you have understood the example. Let's take another example. Convert 1 Newton into dyne. Children, as you know, the dimensions for force are mlt minus 2 and 1 Newton is equal to 1 kg into 1 meter per second square. Children, the CGS unit of force is dyne, so it's equal to 1 gram 1 centimeter per second square. So on dividing Newton and dyne, we will get 1 meter can be written as 100 centimeter and 1 kg can be written as 1000 gram. These values are multiplied and divided by 1 second per square. So the answer comes out to be 100 into 1000 equal to 10 power 5. In this way, we have got the answer 1 Newton equal to 10 power 5 dyne. Children, I hope you have understood the topic. Thank you.